Hello everyone. So this is me again, Jen. So in this video we'll discuss on how to interpret the box and whisker plot. So let me first describe this graph. So here these two blue lines, we call this as whiskers, and this blue rectangle, we call this as the box. So this blue line here down the lower whisker represents the 25% of the distribution, while the entire blue rectangle represents the 50% of the distribution, while the upper whisker represents the 25% of the distribution. So if we add this 25 plus 50 plus 25, so that is 100%. So what can we say from this data? Supposing these are the scores of 15 students. So here we have computed the minimum value, the first quartile, which is 25, third quartile, which is 36, and the maximum value, which is 59. So we can say that the first lowest value is 10 and the highest value is 59. We can also see it here in our graph. So the lowest end of the whisker, this is 10, and the highest end of the whisker, this is 59. So that would be our first analysis. Next, we can also compute for the median. So how to compute for the median? So we can use the formula. So that is equals, you can type median, you can click this function, okay, then click the value or type the value. So the value, or you can click this part, then click 10. Oops, so let me do that again. So the median is between A1 to A15. So therefore the median is 33. So we can state it that the median score of the distribution is 33. It is somewhere here. Okay. So what else? What can we describe? So we can describe the blue rectangle. So we have discussed earlier that is the 50% of the distribution. So that is between 25 and 36. So we can say that the middle 50% of the students got a score within the range of 25 to 36. Okay. Next, how about this whisker here? So this represents the 25% of the distribution, but that is below 25, which is the first quartile. So we can say that this portion, it means that 25% of the students got a score below 25. How about here? This endpoint is 36, or the third quartile. So what can we say above 36? So that means 25% of the students get a score of above the 36. Here we can also describe the distribution based on interquartile range. So we have a formula on getting the interquartile range. So that is equals third quartile minus the first quartile. So that is 11. So we can say that the interquartile range is 11. Since we already have the value for the interquartile range, which is 11, we will use this to get the boundary for the upper and lower fence. So let's start with the boundary for the lower fence. To get the boundary of the lower fence, we can have fence here. Okay, we can use the formula equals The first quartile value is 25 minus 1.5. 1.5 here is constant times the interquartile range, which is 11. So that will give us 8.5. So that is the real boundary of the lower fence. So we can say that the boundary of the lower fence is 8.5, and the value that falls lower or lesser than 8.5 is considered as an outlier. So next, how about the boundary of the upper fence? We can have equals the value of the third quartile, which is 36, plus 1.5. Again here 1.5 is constant, times 11, which is the interquartile range. So that will give us 52.5. So this means all the values above, okay, above 52.5 is considered an outlier. In other words, the boundary for the upper fence is 52.5. So from this data set, can we see an outlier? Okay. Can we say that 10 is an outlier? No. Why? Because it falls between 8.5 and 52.5. Okay. How about 59? Is 59 an outlier? Yes, 59 is an outlier because it falls outside this fence or this range. It does not belong to 8.5 to 52.5. So any value that goes beyond 8.5 and 52.5, we can consider it as an outlier. So in this case, the score 10 is not an outlier, but 59 is an outlier. So there you go. That's how we interpret the box and Whisker plot. Thank you for watching.